Hey guys, welcome to our exploration. In this video, we're going to continue to investigate our unit question, which is how can we use environmental and genetic factors to explain changes in organisms? However, we're going to focus on the environmental factors, starting with air masses. So in our journey today, we're going to make two stops. The first is a review of air masses, and the second is applying our learnings to some practice activities. So let's begin. The first thing we want to note is that Earth is tilted, right? And so different locations on our planet receive different amounts of direct sunlight. So let's take a look at this online model. And I want you to note that it records the sunbeam inclination and also the intensity of that sunlight, right? So as I told you before, the areas that are closest to the equator get the greatest amount of direct sunlight. So I'm going to be shifting or moving this horizontal red line so that we can record the intensity of the light at different points. So let's move that horizontal line and place it on top of the equator, right? If we place it on top of the equator, we have an intensity of 92%. Why? Because we have a lot of direct sunlight, right? So those areas close to the equator tend to be warmer because they receive more direct sunlight. However, observe what occurs to the intensity as we move away from the equator and closer to the North Pole. So now we have an intensity of about, let's stop at this point here, 26%, right? And if we move even further away and closer to the poles, the intensity continues to decrease. So why is that? Well, at the poles, we don't receive as much direct sunlight. We actually receive a lot of indirect sunlight. And so the intensity is less and the poles are cooler because of that. So let's summarize our learnings. We learned that areas near the equator are warmer, right? Because they receive more direct sunlight. However, as you move away from the equator, the temperature starts to decrease and it starts to get cooler. Now, why do we even care about this? Well, it's important to note that depending on where the air mass forms, you're going to have different characteristics, including temperature. So those air masses that are closer to the poles tend to be cooler, and those closer to the equator tend to be warmer. So let's do a little practice. First and foremost, we learned that air masses take on the characteristics of the regions they form in. So I'll have some tools here to change characteristics of the air, right? And we're all familiar with these tools. We have an air conditioner, right? And how does it change the characteristic? It cools the air. A heater heats the air, and a humidifier adds water to the air. So now I want you to describe the characteristics of the air masses below. And so you're going to observe the air mass and you're going to see what tools are inside the air mass that are affecting those characteristics. And you're going to either circle for temperature cold or warm, and for humidity, dry or wet. So at this point, you can pause the video, try these two problems out, and then when you're done, press play to go over it as a team. All right, so I hope you guys had some good practice there. Let's go over these air masses together. So if we observe air mass A, we notice that there's an air conditioner and a humidifier. So I know that air conditioners make the air cooler. That's why we love to turn them on in the summer. So I'm gonna say that the temperature is cold. Now there's a humidifier, and we know humidifiers add water to the air. So I'm gonna go ahead and circle wet for humidity. Therefore, I can say that air mass A is cold and wet. Now, if we observe air mass B, we would notice that there's a heater. And so for temperature, I'm going to circle warm because we know that heaters heat up the air. And I also observe that there's no humidifier. So there's nothing adding water to the air, and I'm going to say that it's dry. So I hope this activity helped you understand some characteristics of air masses, specifically temperature and humidity, by using things we're all familiar with that many of us have at home, right? So let's quickly review what we've learned so far. We know, based on the previous activity, that an air mass is a large body of air with roughly the same temperature and humidity. Now, let's continue our practice and let's use some models. So we're going to model air masses, and we have 4 different tanks, and there's different conditions for each tank. Keep in mind that in some models, the lamp is on, and in others, the lamp is off. And I want you to carefully observe each tank and determine both the temperature and the humidity for each model. So you can go ahead and press pause and try that out, and then we'll come back and we'll review it together. So welcome back. Let's go over each model one by one and determine what the temperature and humidity are in each situation. So for the first model, we see a tank and we see sand, and we notice that the lamp is off. So if the lamp is off, then the heat source is kind of gone, right? So I would say that the temperature is cold. I notice that the tank has sand, but there's no water. So I will go ahead and say that it's dry. For tank 2, we see that the light is on, right? So there is some transfer of energy there, right? Heat energy. And so the temperature is warm. And given that the tank has no water, just sand, I'm going to say the humidity is dry. Now for tank 3 or model 3, the lamp is off, but there's water. So the temperature is cold and the humidity is wet because there's the presence of water. For the 4th model, the lamp is on and there is water. So I will go ahead and circle warm for temperature and wet for humidity. So here is a visual of all the air masses. And now let's go over the air mass key. So let's transfer what we learned previously to what we're going to do moving forward. So C is a symbol or the letter that stands for continental, a continental air mass. That means it's above land and it's dry. The M stands for marine, which means that it's above oceans and that air mass is wet. Arctic, right, means that it is in the Arctic region or from the Arctic region. So it's very cold. And you have the symbol A or the letter A that represents that. The letter P represents polar, meaning that the air mass is from the polar region and it's cold. And T stands for tropical, which means that it's warm. Also notice how the air masses close to the equator are in red, because that means they're pretty hot. And the orange ones also mean that they're warm. But as you move away from the equator, the colors start to change, right? So light blue and dark blue, because that means that the air masses are getting cooler since they're receiving less intense and less direct sunlight. So now that we've gone over our air mass key, I want you guys to practice identifying the different air masses. So you have two boxes for each air mass that's numbered. One is yellow and one is white. So in the yellow box, you're going to identify the humidity, okay? So if it's dry, you're going to write in continental. If it's wet, you're going to write in maritime. Now for the white box, you're going to identify the temperature. So you're either going to be writing polar, if it's cold, right? Or tropical if it's warm. So that's why air masses, as we discussed, right, are described by their temperature and humidity. And that's why you have two boxes. So for each air mass, based on its location here, you can identify both its humidity and its temperature. So before you go ahead and ace that practice, I want to remind you that air masses can move from area to area, right? And what's responsible for moving them is wind. So if you have an air mass that developed in a region that was hot and humid, then when it moves to a new location, it's going to bring initially those characteristics with it. So with that said, I'm going to let you go and practice and impress your teachers and do the best that you can. You guys are more than ready to ace this assignment. Take care.